I am Jamin and my friend Genius have prepared an animation on topic fatigue failure for our term assignment. It is guided by Professor Sashikant Joshi and Professor Dhaval Shah. Components which are subjected to loading which varies with time can fail at stresses well below the ultimate tensile strength of material. This is called fatigue failure. It accounts for a vast majority of mechanical engineering failures worldwide. The bolts in an office chair, the crank arm in your bicycle, and the pressurized oil pipelines are just a few examples of components which are subjected to time varying loads and may be at a risk of fatigue failure. Why does fatigue failure occurs? Fatigue failure occurs due to the formation and propagation of cracks. It is a three-stage process. Stage 1 is crack formation. This usually occurs at free surfaces and at stress concentrations. Stage 2 is the crack grows in size. And in stage 3, after crack has grown to a critical size, fracture occurs. Now, to figure out whether a component is likely to fail due to fatigue, we run a fatigue test as a common approach by subjecting a component or a test piece to a large number of constant amplitude stress cycles and counting the number of cycles until it fractures. If we repeat this test a large number of times with different applied stress ranges, we can plot the results on a graph with the number of cycles to failure on horizontal axis and the applied stress range S on the vertical axis. By plotting a curve to the data points, we obtain a graph which is known as a SN curve. The SN curve allows us to calculate the number of cycles until a component is likely to fail for a given stress range. For example, if we have a stress range of 100 megapascal, then SN curve tells us that the number of cycles to failure is 5 lakhs. If we know that our component is subjected to 1 cycle per minute, we could predict that our component will fail due to fatigue after approximately 1 year. For some materials, and in particular ferrous materials, it is important to note that the SN curve at a very large number of cycles becomes an horizontal line. This is known as endurance limit. Theoretically, the component could be cycled at stress ranges below this level forever, means it will never fail due to fatigue. This makes the endurance limit an important fatigue design parameter. It is common to differentiate between a high cycle and a low cycle fatigue. High cycle fatigue occurs when the applied cyclical stresses are low and failure occurs after a very large number of cycles, typically more than 10,000 cycles. Because the stresses are low, we are only dealing with elastic deformation. While low cycle fatigues involves higher applied cyclical stresses, and failure occurs after fewer cycles. Because the stresses involved are above the material yield stress, both elastic and plastic deformation occurs. In these cases, a strain-based approach using, for example, a Coffin-Manson relation is usually preferred to the SN curve approach. Now, if we look at the data from our fatigue test, we can see that there is a large amount of variation in the data. This is typical for fatigue test even when identical test pieces are used. If we use a best fit SN curve as done here, there is a significant possibility that our component will fail at a much smaller number of cycles than the curve predicts. This test piece, for example, failed at a much lower number of cycles than predicted by our SN curve. For this reason, SN curves published in engineering codes are normally shifted downwards by a certain number of standard deviations to give reduced probability of failure. Here, by shifting the mean curve down on the vertical axis by 2 standard deviations, we have reduced the probability of failure from 50% to 1%. Fatigue tests are usually run for the constant amplitude fully reversing cycles. As we can see here in the graph, the same stress magnitude is applied in tension and compression. The stress range is defined as the difference between maximum and minimum stresses, while the stress amplitude is defined as half the stress range. The mean stress is the average of minimum and maximum stresses. In this case, the mean stress is 0, but this is only one very specific type of loading. In some cases, we might have a mean stress which is not equal to 0 as shown here. This means stress will have an effect on fatigue life. A tensile mean stress means shorter fatigue life. One way to account for a tensile mean stress is to use SN curve for specific values of mean stress. Thank you.